In this video, I'm going to be taking you through agency CMOs, and CMO stands for Collateralized Mortgage Obligations. So a quick overview of how this fits into the course and what we've learned so far. We started off in Chapter 11 with single mortgages. So we talked about things like fixed rate mortgages versus adjustable rate mortgages, prime versus subprime mortgages, and we also looked at simple amortization tables and using the amortization function in the financial calculator to get things like scheduled principal, scheduled interest, or the balance remaining. Now, next up, we looked at agency mortgage-backed securities, right? So agency, that means it's some type of Fannie Mae, Freddie Mac, or Ginnie Mae security. And what they're doing is they're pooling together a group of conforming mortgages. So Fannie Mae and Freddie Mac group together pools of conforming mortgages and they issue mortgage-backed securities. So now if you own one of those mortgage-backed securities, you're receiving the interest and principal, right, or a fraction of the interest that those homeowners are paying. Now, the trouble with mortgage-backed securities is that you can be exposed to what's called prepayment risk. And that comes in two forms. There's extension risk, which is when rates increase and prepayment goes down. So the security lasts for a longer time period than you were previously expecting. And then there's contraction risk, which is when rates go down and prepayments go up. So the security ends up lasting for a shorter time period than what you were expecting. Now, what we're doing next is we're going to basically take a mortgage-backed security, but we're going to divide it into different classes, or if you've heard the term tranches before, we're going to divide it into different tranches, and the different tranches depend on prepayment speed. So if you're trying to prevent too much prepayment from happening, you could do something like buying a later tranche. And I'll show you exactly what that means and all the math associated with it. The other document I'm going to be using throughout this video is the problems associated with this chapter. So first, I have one example that came right from Febosi, and this is from Exhibit 13.2. So I'll go through the math of what's happening here as one tranche ends and the next one starts. And then I also have a second example, which is showing the difference between a sequential CMO versus a sequential plus a Z, or an accrual. And both this PowerPoint and those practice problems you'll find linked either down below this video or in the resources area. Now, as I mentioned, a collateralized mortgage obligation, or a CMO, it's kind of like a subcategory of a mortgage pass-through security. So it's just one version. There is also stripped versions, so I'll talk about those at the very end of this PowerPoint as well. An overview of CMOs. CMO stands for Collateralized Mortgage Obligations. And what they're doing is they're trying to reduce prepayment risk, which is one of the biggest risks that agency pass-throughs are exposed to. So they were first introduced in the 80s, and it's similar to a mortgage pass-through security in that all the cash flows come from a large pool of mortgages. But what makes them different is that the principal and interest are distributed to the different classes or tranches of bondholders at different times. So each class or tranche usually has a different principal, coupon rate, maturity, and prepayment risk. Now here we have an example of what's called a sequential CMO. And what sequential means is that in this case, each one of the different tranches matures sequentially. So in the example here, we have 4 different tranches. So we have A, B, C, and D. And what would happen is first, tranche A would come up. So tranche A is going to first receive all of the principal, right? All of the principal that all of the homeowners in that pool of mortgages are paying. And tranche A is going to keep on receiving the principal until the full par value or par amount is paid off. So once that $194,500,000 is paid off, then tranche A is going to end, and we would move on to applying all of the principal to paying down tranche B, right? So that's going to keep on receiving all of the principal until the total par amount of $36 million is paid off. then B would end, right? Then we would go on to C, and then lastly D. Now, in the purpose of this example, the coupon rate for all of these are going to be equal to each other. In reality, the coupon rates of all the different tranches would not be equal, right? They would correspond to the risk you're taking on and the average life of each of the different tranches. Now, a quick summary of how the cash flows are going to work for a CMO. All tranches are going to receive interest payments from the pool of mortgages, right? So let's think about month one in what you've done before, a pass-through security. So in month one, tranche A through tranche B are all going to receive their pass-through interest. But only tranche A is going to receive principal. So they're going to receive all the scheduled and all the principal, and they're going to continue to receive that until tranche A is going to paid off. So month after month. Then tranche B is going to start receiving, right, scheduled and prepayments until B is paid off, and it keeps on going all the way throughout the table. So when we look at the math on the next slide, it actually starts off very similar to the math of a mortgage-backed security or a mortgage pass-through. Just where we're applying the principal is the part that's different. So suppose we had this CMO. So we had 4 different tranches, and we're supposing the weighted average coupon is 8.125%, right? So that's the rate that homeowners are paying. The weighted average maturity is 357 months. We have 165 PSA as our prepayment assumption. And then the coupon rates in this table, these are the pass-through coupon rates. So again, just for simplicity, we're going to assume the pass-through coupon rate for each different tranche is exactly the same, and it's 7.5. The other number that's important is we want the sum of this principal balance column. So the sum of this principal balance column is $400 million. So first up, we want to determine the total payment that's going to be made. So first, we have our weighted average maturity. So that's our 357. Our I is our weighted average coupon, right? The rate that homeowners are paying. We're making it monthly. Present value, that came from our total principal balance. And I didn't put a negative sign in there, but I would make that your negative value. And then you're solving for what the payment is. Now, what is this payment number? Right, this payment number is what we're now going to divide into scheduled principal and interest. So for determining what the interest paid is going to be, the interest paid, first let's think about the rate homeowners are paying. So this numerator here is my weighted average coupon. I'm making it monthly, and I'm multiplying it by that beginning balance. So the total amount of interest homeowners are paying, it would be the $2,708,333. So let me label that one, total interest homeowners are paying. Now, in my table, I actually want to put interest to investors, not total interest. So the interest that investors are going to be receiving are based on the pass-through rates, right? So all of these 7.5%. So the first tranche, it's going to receive 7.5%, but make it monthly, of the beginning balance. So $194,500,000. And that would give the interest to tranche A $1,215,625. And I'm just going to round all of these to the nearest dollar. Then the next tranche is going to receive their pass-through coupon, make it monthly, times their beginning balance, $36 million. So here I would end up with $225,000. And I'm going to repeat that exact same thing for C and D. So I would end up with $603,125, $456,250. So during the month, right, every tranche that still exists is receiving their interest payment. And their interest payment is based on the pass-through coupon rates. Now, if you add up this column and take the sum of this column, it will not end up equaling the $2,708,333. And the reason they will not be equal is you still have those servicing and guaranteeing fees. So the pass-through rate that investors are receiving is different than the rate that homeowners are paying, that weighted average coupon. Now, last up, we also want to make sure we get our scheduled principal payment. So let me label this one scheduled. So the way we get the scheduled principal payment is we take our payment, which came from the previous slide, and we're going to subtract off the interest that homeowners are paying. So we end up with a scheduled principal payment of $267,535. We still have to get our prepayment. The prepayment is based on 165 PSA. So first we do our conditional prepayment rate, and we're still below 30 months of the mortgage. So we're going to do 6% times T over 30. We factor in the 1.65. We switch it to monthly, so we have our single monthly mortality rate. And then lastly, using that single monthly mortality rate, we multiply it by the beginning balance minus our scheduled principal. And that gives us our prepayment of $442,388. So the total principal paid ends up being the scheduled number plus the prepayment, which is the $709,923. Now, where does all of that principal go? It all goes towards Tranche A. So Tranche A, right, that is a sequential CMO. So Tranche A has to be paid down fully before B, C, or D will even start to receive their principal payments. So this full $709,923 is going to go towards paying down the $194,500,000. So last up, getting the ending balance, we would take the $194 million, subtract off the $709,000, and we have our new ending balance number. Now, thinking about the next month, what would happen then? We're basically back to the beginning, but we've updated that principal balance at the beginning. So we would repeat the exact same steps now, but thinking about our inputs, let me draw out my time value of money. So my N, I'm going to decrease by 1. So now I have 356 months. My I is that weighted average coupon. Make it monthly. Present value is my new beginning balance. I'm going to make that my negative number. And payment is what I'm solving for. Future value 0. So the payment I get now is $2,972,575. So now I want to take that payment and I'm going to divide it into interest and principal. So my interest is the weighted average coupon, make it monthly, times my beginning balance, and that gives me the interest paid of $2,703,527. I can get my scheduled principal, and my scheduled principal should be my payment minus my interest number. So my payment was $2,972,575 minus the number we just got. So I have scheduled principal of $269,048. Now, my interest column, I already have these filled in here. You'll notice that B, C, and D, nothing changed here. And the reason nothing changed here is because all of their beginning balances were exactly the same. So I was just doing 0.075 over 12 times the beginning balance, right? Same thing for all three. So you'll end up with the exact same three values. The first one changed. And the reason the first one changed is because the beginning balance is now a smaller number. So I was doing 0.075 over 12 times the new beginning balance of $193,790,077. Now, next up, we have scheduled principal. We also need prepayment. So prepayment, again, I'm going to go through the steps of doing my conditional prepayment rate. Now my T would be 5 instead of 6. And I'm going to take into account the 165 PSA. I'm going to make that one monthly, so I'm going to get my single monthly mortality rate. And then lastly, my prepayment would end up being that single monthly mortality rate times my beginning balance minus my scheduled principal. So prepayment, $552,848. So in total, I have prepayment of $552,848, and I have my scheduled principal of the $269,000. So going towards tranche A, I'm going to have beginning balance of $193,790,077 minus $269,048 minus $552,848. And now, I already did this math out, my new ending balance, or the beginning balance for the next month, would end up being $192,968,181. And I would keep on going until I finished paying off the principal of tranche A. So what does that actually end up looking like? This is where the activity comes into play. So in this activity, what we're looking at is we have the exact same security. So it has a weighted average coupon of 8.125. At the beginning, or for the first row of this table, it had the weighted average maturity of 357 months, 165 PSA, and all of our values over here to the side, right? They started off in the exact same place. Where are we now? We're now supposing we're at month 80 and we're going into month 81 and then 82. So tranche A is just about to end. The balance here is only just above $2 million. And we're going to start paying down tranche B. First thing we need to do is figure out the beginning balance, right, for basically month 81. So the beginning balance for month 81 should be the ending balance from the previous month. So the previous month had a balance for tranche A of $2,362,000, and then it paid towards principal the $2,050,000. So the ending balance for A should be $2,362,347 minus the principal. And that principal is the way it's displayed in the table. That is both scheduled principal and prepayment. So A ends up with $311,925. B has not been paid off yet, so it still has the full $36 million. C also has not paid off, so it has the $96.5 million. And then D, still the $73 million. So the beginning balance across all the tranches for month 81 should be $205,811,925. And first going through and filling in that beginning balance value. I've added in the $311,925 for A, and for B, $36 million. Just like we did before in the PowerPoint, let me go back up to that first month. We need to basically solve the time value of money, but now instead of it being row 1, where N was 357, we're now on row 81, so we want to figure out what would our N equal. If we count down, so we think month 1 in the table is the original 357, month 2 would be 356. So when I get to month 81, I end up with 277 is my N value. So let me start a new page here and start off with getting the payment, write out my time value of money, N 277. I is still that weighted average coupon, so the 8.125, make it monthly. Present value, that's our loan amount, so that we just got the 205 million number. Payment's what we're solving for. Future value 0. Solving for that payment gives a value of $1,647,666. Now with that payment, what are we going to do next? We're going to divide that into interest and the scheduled principal. So interest, based on the weighted average coupon, ends up being 0.08125 over 12 times the beginning balance that month, $1,393,518. Now the scheduled principal is the payment minus the interest $254,148. If I also wanted to fill in the interest paid to the different tranches, the interest paid to tranche A, right, or the value that goes right there where I just highlighted, that would be the pass-through coupon rate. So that would be the 7.5% over 12 times the beginning balance of the $311,925. Same thing goes for tranche B. You would be doing the 36 million times the 0.075 over 12, and you would actually end up with the exact same number here, the $225,000. Filling in tranche A values as well. Again, that's the 0.075 over 12 times the beginning balance of the $311,925. In terms of prepayment next, prepayment, usually we're in the first 30 months of a mortgage, so we're thinking about doing the 6% times T over 30. In this case, we're actually way past the 30th month of a mortgage, so it would just be 6% times the 165 PSA, and then we need to make that monthly. So we would calculate the single monthly mortality rate. Once we have that single monthly mortality rate, we would multiply that by the beginning balance, So the $205,811,925 minus the scheduled principal of $254,148, resulting in a prepayment of $1,778,049. In total, the amount of principal we have is we have this scheduled principal and we have this prepayment number. And what you're going to notice is that the sum of those two numbers, adding these two values together, gives us $2,032,197, which is much larger than the amount that's left to be paid in Tranche A. So what do we need to do? We actually need to pay off the amount remaining in Tranche A, and then anything that's left over is now going to start paying down Tranche B. Let me add in another blank page here. So going towards Tranche A, I'm going to have the full $311,925 paid off. How much is remaining now that can go towards Tranche B? Would be the sum. So the $2,032,197 minus the $311,925, or $1,720,272. This is going towards B. Let me fill in these numbers in the table real quick. So principal going towards A, we're paying that one off fully. And because the scheduled principal plus the prepayment was significantly larger than the amount of money we needed, or really just larger in general, now we can pay down part of B. So B ends up getting paid down by $1,720,272. The next row, what it's now going to look like is Tranche A now has a balance of $0. So A, at row 82, A has ended. So A does not get any more principal and it does not get any more interest. B, on the other hand, though, we're essentially just starting to pay that one down. So looking at our balance the previous month, the $36 million, we paid $1,720,000 towards it. So our beginning balance the next month is $34,279,728. That would be our new value in row 82 for beginning balance. And what would we do there? Now we would go back to this first step again, and we would say, okay, now it's really just 276 periods. Our new present value is the amount remaining from B, C, and D. A has gone away. Right, in terms of the interest, you would calculate this one just from B, C, and D. And you'd go through all the steps. Then at the end, once you have your new amount of scheduled principal and your new amount of prepayment, now all of that money is just going to go towards paying down Tranche B. And you would keep on paying down Tranche B until B is fully paid off. Then you're going to move on to C. So this example shows what happens when one tranche gets paid off and you're essentially just beginning to start paying the next tranche. Now that we figured out all of the math for a sequential CMO, we want to think about how this actually protects us from prepayment risk. And essentially, how it protects or minimizes prepayment risk is based on which type of prepayment risk you're afraid of. You would be more drawn to purchasing one of the different types of the tranches, or an earlier tranche versus a later tranche. So let's say you're afraid of extension risk. So extension risk, that's the risk that rates are going to increase. And if rates increase, people are going to stop prepaying, or prepayment is going to slow down. So your security is going to end up being much longer than you originally thought it was going to be. Now, how could you avoid this? By purchasing a specific type of tranche in an agency CMO. If you're afraid that your security is going to last for a longer time period than what you previously expected, right, you essentially want to get out of your security as quickly as possible. And if you're trying to get out of that security as quickly as possible, you want the shortest security, or the one that's paid off first, right? So in this example, with extension risk, you would be most interested in one of those earlier tranches, right? So something like A or B. Now, if the opposite is true, and now you're afraid of contraction risk, so contraction risk is the risk that rates are going to decline, and when rates decline, prepayment goes up. So the length of the investment is going to shorten. But you don't want your investment to shorten. So a way you could avoid this or minimize this is through purchasing a CMO and one of the later tranches of a CMO. So the later tranches of the CMO, right, if you buy a C or a D, those don't even start receiving principal until both A and B have been paid off. So you're making sure your security is going to last for as long of a time period as it could. And essentially it has that A and B, the A and B tranches, to kind of buffer it before it starts receiving its cash flows. So it'll make your security last a longer time period than the earlier tranches. Another way that you can kind of play around with extension risk versus contraction risk is, instead of just having a sequential, you can add in something called an accrual tranche. In this example, we now have 3 tranches. So we have the sequential, which is A, B, C, and then we added on an accrual tranche. So instead of D, it's now just become Z. This Z tranche does not actually receive any coupons. So it's a little bit strange that it looks like it has a coupon rate over here in green, right? It says 7.5, but that's not actually really a coupon rate. That's the rate at which the par amount is going to be growing each period. So instead of actually receiving the 7.5% coupon each period, or interest, the par amount is going to increase by 7.5%. And where that interest is going to go is that interest is going to go towards paying down the principals in the other tranches. So for example, the first months, right, all the way up through whatever month it may end up ending, all of that interest that would have gone towards Z is now actually going to go towards paying down A. What does this do in the grand scheme of things? So what this does is this actually shortens the lives of the earlier tranches. So it's going to protect those earlier tranches from extension risk. So now, not only will A receive all of the scheduled principal, all of the prepayment, but it's also going to receive the interest that Z would have received, right? So now essentially it's receiving like 3 cash flows each period. And A is going to receive that all the way until A is paid off. Then B is going to start receiving all 3 of those cash flows. So if we go through the all month by month of each one of these different schedules, A, B, and C will all have shorter lives than they did when it was just a sequential. Looking at the math, again, the only thing that's different is now instead of D, it says Z. So first up, we would take the total amount of principal, the characteristics of our pool, which stayed the same as the previous examples, and we would solve for our payment number. Now with that payment, we're going to divide it into interest and principal. So the interest, again, is based on that weighted average coupon, multiplying it by the beginning balance. That number actually stays exactly the same. Now principal, We're going to do the payment minus the interest. And again, that number is also the same. What's changing is actually what's up above in this table. So first, Tranche A is receiving their regular interest payment. Tranche B is receiving their regular interest payment. Same with C. But Z is going to get $0 in interest. Based on their coupon rate, they should have gotten 7.5%. But that 7.5% over 12, make it monthly, or the $456,250 is actually instead going to be added on to their principal balance. So the way I've written this is now they're going to take their beginning balance and they're going to grow it at that pass-through coupon rate. Looking at the next table, what's happened is now our principal balance has increased by the $456,250. Z is going to receive no interest. And instead of receiving their interest, now Tranche A gets the scheduled, they get the prepayment, and they get the interest from Z. So in total, the cash flow to Tranche A is increasing. Now the new ending balance is going to be a lower number. So the ending balance after the first month ends up being $193,333,827. And then you would work through that again for the next row in the table. And this exact same example, we actually have in the second page of that worksheet. So what we want to think about as we're looking at this example is essentially what's the same versus the original and what's different, right? How are the cash flows changing? So on the left side of the screen, we have just a sequential. So it's A, B, C, D, right? The sum of all of the principals is the $400 million. They all have coupons of 7.5. Then on the other side, or the right-hand side here, we have 3 sequentials and then an accrual tranche. All the coupons, again, are 7.5, and the total is $400 million. And the quick note I have below the Z, right? No interest payments. Instead, the interest is used towards paying down the principals of earlier tranches. The interest accrues on that par amount for Z. Now, first up, getting the payment. So if I look at the left side of the screen, my N is 357. My I is based on my weighted average coupon. Starting balance is the $400 million, and I solve for that payment. Now, if I were to calculate that for a sequential plus a Z, there actually is no change here. We would be using that exact same payment number. Next up, dividing that payment into interest and principal. So first, the interest is based on the beginning balance. That would stay exactly the same. And then the principal, right, the payment, which we already know is the same number, minus the interest, $267,000. No change. It stays exactly the same. Prepayment step, right? So prepayment, that's based on the month that we are in that pass-through security. So based on whatever the T is, nothing here would change, right? The beginning balance is the same. The scheduled principal is the same. The prepayment stays the same. So no change again. Last up, filling in the tables. So I have 3 columns here. I have interest, and that's going to be based on the pass-through interest, right? So the interest that investors are receiving. Then principal, so the amount paid towards principal, and lastly, the ending balance. Filling in the one over here on the right-hand side based on the sequential plus a Z. First, for Tranche A, we're going to have the exact same interest payment. So we would still have the $1,215,625. B and C are also going to stay exactly the same. So B, we end up with the $225,000, and C, the $603,125. Z is where it's different. So Z is going to get $0 in interest. Then for principal, first we're going to have the regular scheduled principal. So that's $267,535 plus the prepayment, $442,389. And now we have another new term, $456,250. So that's the interest that would have gone to Z is now going towards paying down the principal of A. In the other two values, or other three values, I'm going to write those all as 0. The reason I'm putting Z as 0, even though the principal value is going up higher, it's accruing onto essentially the ending balance. It's not actually being paid out as a cash flow. So for Z, I'm going to leave the principal as that one as 0. Now my ending balance, that would be the beginning balance. So for A, $194,500,000 minus, write that whole box over there, resulting in $193,333,826. B, I have my $36 million. C, I have my $96.5 million. And Z, I have my $73 million, but I'm going to grow it at my pass-through rate. So I end up with an ending balance of $73,456,250. Now, what happened here if I compare across these two tables? So what happened is the ending balance of A decreased by the $456,250, and the ending balance of Z increased by $456,250. So net, those cancel out. So if you were to take the sum of this ending balance column and compare it to the sum of just the sequential column, you end up with the exact same number. So it's all just a difference of where that interest is being allocated to. Now, if you wanted to look at one more month, we could go on to the next month of this exact same table. So over here on the left-hand side, again, I have my sequential. So sequential, I have my ending balance for A. B, C, and D all stay the same. I update my N, so it switches to 356. Still the weighted average coupon, the new total of the column, and I solve for what my payment is. If I'm doing the exact same thing on the other table, right, I have my ending balances that I'll fill in here real quick. These ending balances are, again, as I just mentioned, the exact same number, right? The A ending balance went down by the 456,000 and the Z ending balance went up by 456,000. So those two just cancel each other out. So the ending sums are exactly the same. So in terms of the payment, there is no change. Now next up, if I look at interest and principal, again, these are just based on that beginning balance and the payment, which stays the same. So again, there would be no change. Prepayment, right? Again, just based on the exact same above numbers, there would be no change there. All that's going to be different is where the interest from Z is allocated to. So A is going to receive $1,208,336. And where's that number from? That is from the beginning balance of A times the pass-through coupon over 12. B and C won't change, so that's still $225,000 and the $603,125. Z is going to get $0. The interest it would have gotten would be its beginning balance times the pass-through coupon rate of 0.075 over 12. That is $459,102. So for the principal column, now in addition to getting the scheduled principal plus the prepayment, it's also going to get the interest that would have gone to Z. So writing those three numbers in, we have the scheduled $269,048 plus the prepayment $552,847 plus the interest that would have gone to Z. So $459,102. The other three tranches are all going to get 0. Ending balance, right now we're basically taking the beginning balance and we're subtracting off all three of those numbers, resulting in $192,052,829. B stays the same at $36 million. C stays the same at $96.5 million. And Z goes up by their pass-through coupon rate. So we would end up with $73,915,352. And to write out where that number came from, I'll write this on the page down here because I'm running out of space. That would be the beginning balance growing at the pass-through rate. Now, just like it happened previously, the sum of this column over on the left-hand side is going to be exactly equal to the sum of the column over on the right-hand side. And the reason for that is we're just switching right where that interest is allocated to. So we're making A go down by the 459,000 and we're making Z go up by the 459,000. So net they cancel out and you'd end up with the sum, the same exact sum across the two tables. So that is mechanically how the two would be related to each other. Now there are a few follow-up questions here. And if we look at these real quick, question 1 says, of the 8 tranches, which would have the shortest average life and why? So I'm going to pause here for you to think about this one. Okay, so hopefully you've taken a guess as to what your final answer is here. And the correct answer is, I'll highlight it in pink, you would want the A tranche of the sequential plus a Z. And the reason for that is first you're looking for the shortest average life, right? So you want whatever ends the earliest or ends the fastest. So that would draw you towards, right, A of either version. But now you want to think about what other types of tranches is each A associated with. So over on the left-hand side, this is just a sequential pay, right? So A gets the scheduled and the prepayment until A is fully paid off, then it goes to B. Versus if you had the sequential plus the Z, A actually ends up getting paid down faster because not only is it receiving the scheduled principal, the prepayment, but it's also receiving the interest that would have gone towards Z. So even if you just look at comparing the ending balances, right, the ending balance of just the second month over here on the right-hand side, it's going down faster. So A of the sequential plus a Z would be the correct answer. The next question says, in this example, we assume the same coupon rate for all 4 tranches in each CMO. Suppose you are evaluating the various tranches with sequential plus Z. Which tranches should have the highest and lowest coupon rates? Why? What types of risk are the tranches you labeled with higher coupon rates more exposed to? So what we want to think about is if we have a sequential plus a Z CMO, would I expect the A and B tranches to have a higher coupon, or would I expect the C and Z tranches to have a higher coupon? The correct answer ends up being the earlier tranches should have the lowest coupon rates, and the later tranches should have the highest. And the reason for this, or even if you could label, right, the C and the Z as the highest there. So the reason for this, and you could explain it with likely various different types of risk, the one I would think about that we focused on in our course is price or interest rate risk. So thinking about which one has the shortest average life versus the longest average life, right? Z has the longest average life. It's the security that lasts for the longest period of time. A has the shortest. And if you think about what types of securities or what characteristics of securities are more exposed to price risk or interest rate risk, the longer the time to maturity, the greater the price risk of the investment. So that is one explanation for why you could give for why a Z tranche would have a higher rate of return, or a C tranche, right? Why would they have higher pass-through coupon rates than an A or a B would? Also included in the slides is more quick quiz questions. So if you're thinking about extension risk or contraction risk, right? What types of tranches would you want to pick? So I'll leave the solution to these quiz questions in the resources as well, so you can test out your knowledge. The last few slides here are other types of tranches. So these ones don't have as much math included for them in the slides. It's more of just a quick overview. So another variation is you could have a floating rate tranche. And what that ends up looking like is you need to split one tranche. So instead of having a C, we split C into a floater and an inverse floater. And oftentimes, institutions prefer investing in floating rate securities because they're a better match for their liabilities. So there can be demand for floating rate securities. In this example here, we split it into the floater, which trades as the SOFR plus 50 basis points. And then we have an equation for the coupon rate, or the pass-through coupon rate, of the inverse floater as well. There's also types of tranches called PAC and support tranches. So what these do is they try to make the cash flows a bit more predictable, specifically within the PAC tranche. So if the prepayments are within a specified range, the cash flow pattern is going to be known. And the reason for this is essentially the PAC tranche gets the priority in the case of where the cash flows are going. Now, to get a better understanding, let's look at an example of how a PAC and a support, they have to come together, would actually occur in a CMO. So we would have to start off with some PSA speed range that we assumed. So it would have to be created assuming some PSA range. And here in this example, it says the PSA range is going to be between 90 and 300. Anywhere in that range, the average life of the PAC is going to stay the same. How they can do that is, let's say homeowners ended up prepaying with a 250 PSA. All of that extra prepayment is going to be going towards the support bond. So this support bond, its job, or the support tranche, its job is essentially to collect the extra prepayments that are happening or to forego cash flows if there aren't enough prepayments. And so what that's doing is essentially this support is taking on a lot more of the risk than the PAC is. So in reality, right, these two shouldn't actually have the exact same coupon rate. So if the length of the support bond varies depending on the PSA. So if the prepayment speed is higher than the assumed range, let's say as an example, it was 400 PSA, right, outside of the 300 range, the support bond is going to mature more quickly. So this support bond, right, its job is essentially to take on those extra prepayments. But what's going to happen is eventually the support bond is going to end up being paid off. So if that support bond gets paid off, now there is no more support bond, and the PAC is kind of left to fend for itself and to actually start receiving those cash flows. If the prepayment speed is lower than the assumed range, the support bondholders may have to forego principal payments, but the PAC's average life can actually stay the same. So this support, you kind of think of it as its job is to protect the PAC, but the support that it can actually give, or the protection that it can actually give, it's only as good as how long that support bond can last for. So the main risk we just talked about, right, is essentially people prepaying faster. If people prepay much faster than the assumed prepayment speed range, then the support ends and the PAC has no more protection left. The last few slides in here are about, instead of collateralized mortgage obligations, these are stripped mortgage-backed securities. So what they're doing is they're basically turning it into a mortgage-backed security into interest-only or principal-only cash flows, or mortgage strips. The way a principal strip would work is it's a strip value, so it's purchased at a discount from the par, and the yield that the investor is going to receive depends on essentially when people are going to prepay. Let's start with the faster prepayments option and think about what would happen to yield. So if you were invested in a principal-only security, right, think about just a simple example. If you were receiving $100,000 in 5 years versus receiving $100,000 in 2 years, and you paid the exact same amount for each one, right? Suppose you paid $75,000 for each version. Which one are you actually getting a higher rate of return in? You're getting the much higher rate of return in the one where you receive the $100,000 quicker. Same thing goes in this situation, right? So you're waiting for people to prepay their principal. So if people prepay faster, you're earning a higher rate of return on that principal portion. The opposite happens the other direction. So if it was slower, lower yield, that'd be kind of like my top example there, where instead it takes 5 years. Now, next up, if we think about the interest-only strips, these are an interesting security because they have no par value, right? There is no set amount that's due. It's not like a home and the home loan is $400,000, right? We don't know what the interest is going to be. What the investor in an interest-only strip wants is they actually want slower prepayments. So they have the exact opposite incentive to the principal investor who wants faster prepayments. Now, basically the reason for this is as principal is prepaid, the outstanding balance declines and interest payments go down. So if we're thinking about someone, again, we could use the same example we had on the last slide for simplicity. It was $100,000 versus $100,000 after 2 years. Right, in the first example, someone is paying interest for all 5 years up until that $100,000, versus if someone prepays in 2 years, they're only making 2 interest payments. And this is a simple one. It's not actually assuming an amortized security or anything like that. But if someone prepays faster, you're receiving less interest. So you actually want someone to prepay slower so that you receive more of the interest payments, and essentially the principal that's lasting all the way along here in an amortized security is higher with slower prepayments. So that is a brief overview of principal-only strips and interest-only strips.